Welcome to the Sonic Days podcast, home of all things audio. This season was recorded live at Sonic Days 2024. In this episode, we look at how sound can play a vital role in the future of automated vehicles. Remote operation has been proposed as a solution to many of the challenges facing automation. But how can auditory displays support operations in making safer, more efficient decisions? Pontus Larsson, human factor specialist and sound designer at Ictech AB, shares insights on the design of auditory interfaces and studies showing their impact on performance and awareness.
So this is a little bit special area of application of sound, I would say. It's about remote road vehicle operations, so remote driving, for example. My background comes from VR actually and acoustics, virtual acoustics from the beginning. But then I went into automotive displays, like sound for cars and trucks. And I worked at Volvo Trucks for a long time as a sound designer and did a lot of research and development in human factors and human-machine interface. And then since a couple of years, I've been a human factor specialist at a company called Ictech, and I'm also actually mainly spending my time at Volvo Cars together with Fredrik, designing sounds for Volvo Cars and Polestar cars, and doing some research there as well. But this is going to be about my Ictech research about road vehicle, remote road vehicle operation, and but it concerns quite a lot automated road vehicles, like this robot truck that you see in the picture. And automated road vehicles has been like a strong trend at least a couple of years ago, with these kind of concept cars and also pilot test cars and automated trucks, of course, as well. The only, I mean, it's not as strong a trend nowadays, maybe, but there's this one company, this Rømer company, which runs a commercial service around automated vehicles. They have these road taxis running in San Francisco and in Phoenix and Los Angeles at this state. The other ones are a little bit more sort of pilot vehicles and such, but still coming more and more of these real world tests and operations. And why would we want to have automated vehicles? Well, said to have many advantages in terms of efficiency and safety, comfort, allows us to create new types of mobility businesses and services, and increase uptime. We can run the vehicles around the clock, basically, when we don't have any human drivers. But automated vehicles come with some problems. The one problem which has been seen that it requires some degree of human supervision. So the vehicles that you can buy today as a consumer, there are mostly on this level 2 automation, which requires you to always stay in the loop and be ready to take over when something happens with the automation. What we really want to reach is this level 4, which is more about being a passenger in the vehicle, which is this Waymo robotaxi service, for example, or the GM Cruise that you see below there. Or for that sake, a automated robot truck, which doesn't have any passenger at all in it. It's just a autonomous pod driving around with fully automated features. But the level 4 automation means that you can run this operation within a certain area or certain conditions. And that's what I'm gonna base my reasoning here, why we need remote driving on. Why would you need remote driving when the vehicle is autonomous? Well, it's not that it will solve all cases, this automation. There are certain situations where we need some kind of human support after all, like when automation fails, when it can't handle the situation. There are fewer and fewer of these cases, but at some point a human needs to go in and solve the situation and help the automation. There could also be cases where we want to drive in or through areas where the automation doesn't work. So driving outside the operational design domain, or ODD as it's called. It can also be as a replacement for automation. For example, if you want to have a car sharing service, you want to move the car remotely without there being any person in it, like an operated valet service. And automation fails sometimes, as I said. This is an example of this Waymo taxi getting stuck. This is a couple of years back, so it's maybe not that bad today, but...
Okay, so we're backing out.
So it's standing in the middle of the road here, blocking traffic. And doesn't know what to do, really.
Very interesting.
So in this case, the remote support person cannot really help, but just comfort the passenger. But it would have been nice if she could have actually driven the car, or at least instructed the car how to move around these obstacles.
Yes, for example, like have some kind of a remote, like
some kind of remote capabilities. And the other case I talked about is driving through this area in the middle here, where maybe automation is not possible. You can have remote driving or some kind of supervised assistance to the car, so it can move through this area where you don't have any possibilities to run automation. And the next example is this.
You need a ride? Simply order away, and a professionally trained teledriver will get to work. As soon as your way arrives, you take control of the vehicle, while our teledrivers can already accept the next order.
Yeah. So in this case, you don't have any automation in the car, but the teledriver sort of moves the car to the next customer. And it's not like this is only about actually driving the car, this remote operations. It could also be assistance, where you're more like telling the car what to do. It still runs automatically, but you're maybe drawing the path for it and explain what kind of obstacle it has in front of it. Or it could also be remote monitoring, where you have a fleet of cars that you're supervising and optimizing the flow for. But I'm mostly going to talk about remote driving in this presentation. This is an example of a company called Zoox. That's about this remote monitoring. Could be like you have a control desk like this, and you have a lot of stats. You have the map with all the vehicles, and you're optimizing the traffic flow or responding to alarms in the system. Maybe go into this assistant mode here.
it's like they see the vehicles based on what, on like GPS.
Yeah, you have a lot of signals, both like their position and all kinds of vehicle signals comes from these vehicles that you can pull into this system and sort of monitor the status of the whole fleet of vehicles. But the common thing is that, of course, you need to make this safe and efficient. It might look like driving a video game, but of course, this is for real. So you have to make sure that it runs smoothly and allows you to drive in a safe way. You need to have good situational and spatial awareness. You need to know how fast you're going. You need to be able maybe to communicate with other road users, as we saw in the Waymo video. And it shouldn't be overloading to your senses. It should sort of allow you to take in all this information without being stressed or unable to perform your task, of course. And the vision that we have had in our investigations is that it should be safer than if you would have sit in the car and drive it normally. So that sounds quite impossible, but you need to have a high reaching goal. But also the fact that you don't have to actually recreate a reality for the operator. You can actually enhance stuff. You can suppress stuff. I mean, you don't have to have excessive road noise for the operator. You can take away the unnecessary road noise. Maybe have just the informative noise or sound from the car. You could have additional views, visual views, since you have a lot of cameras on these vehicles, and you can have additional sensors also that you present, and the information from these sensors you present to the operator to sort of give them sort of supernatural perception abilities, even though you're on a remote place driving these cars or trucks. So we took the approach of see what you can do with sound in these remote driving setups or scenarios. Of course, as in almost all other businesses, sound is the last thing you think of. It's comes last in the chain. You talk about and look about these visual displays, but sound is in general underdeveloped in these remote operations. But of course, it can be used for many purposes. First and foremost, we have all the information warning sounds that you have in cars, like turning signal and collision warnings and stuff like that. But it can also be used to improve the sense of speed and the sensation of that you're actually moving. It could be used to improve the awareness of the vehicle that you're controlling. How is it working properly? It could be used to perhaps improve the situation awareness, give you a sensation of that, what kind of objects you have around you, bicycles, pedestrians and stuff. It could also enhance the sensation of actually being inside the vehicle, feeling that you're driving the car or truck. Sort of give you a more sensation of that this is actually a safety critical thing I'm doing. I'm not just driving a video game, but it feels like I'm actually driving the car. So we can convey a number of things with sound, we think. For example, how fast am I going? What kind of surface am I driving on? How is my remote vehicle working? Its drivetrain and so on. What kind of road users do I have around me? Where am I? What's the weather like? And stuff like this. It's things that you could possibly display with the visual displays as well, but in some cases it might be more efficient to use sound. We can divide the types of sounds into different layers, like sound that curve the operation and propulsion of the vehicle, like the drivetrain, the engine, the road noise, and stuff like that. And if you have any error states of the vehicle, you maybe have a puncture. It might be difficult to see that through a display, but you hear it you hear it very loudly when you drive a truck, for example, if the vehicle explodes, or the tire explodes. Vehicles explodes, you hear that too, of course. You can perhaps display the sound of other road users. You can display ambient background sounds from weather and traffic. You can add this verbal communication, of course, passengers, pedestrian cyclists, and these road workers and emergency personnel and so on. And yeah, least in the chain is the information warning sounds, because that's kind of easy to understand why you need that. And we have devised a technical concept to sort of make this possible. This is all on the research stage, so it's like not a finished product or anything, but just to explain the ideas and principles and to be able to prototype. We kind of made this first. And it's a bit of detail here, but the basic thing is that you have microphone feeds over 5G. You have information from the context, traffic and so on, from the vehicle, and that you also send into this proposed sound application. The microphone signals, and it needs some pre-processing, but then down mixed into binaural rendering, using binaural rendering. The vehicle signals you take and you transform it, or you sonify these signals in the various way and mix with the microphone feeds. And then using head tracking, you can present it to the operator there over headphones. You also allow the user to set the immersion level, so maybe set the mix of sounds that you have. So maybe sometimes you only want to hear the microphone feeds, sometimes you want this augmented sound on top of that. So basically you're in control of what you want to listen to, which is also an advantage of a real situation where you have to accept what you listen to, basically. Cannot change so much. And what we created is an audio rendering software for remote operation use cases called Lava, developed in Max. I don't know if you have used Max before. Yeah, so you know what that is. yeah, it has this binaural downwave mix of multi-microphone streams. We have this augmented spatial sound, augmented propulsion sound, and some more features. So we created this to be able to test, does it make sense and does it work even at all? And yeah, this is just GUI settings that you can vary at the moment. And gonna focus on the microphone features first. So we did the test with this RoboPod. It's a Swedish company called Enride that makes these autonomous trucks, basically. We put microphones around the truck or the pod in this very, very wide spaced array setup. And used this Lava software to downmix into binaural. So basically, having a virtual source for each microphone here. So what this makes possible is that you can turn your head around and listen to different microphone feeds, basically. It's like having almost supernatural hearing, that you can take in the sound from this kind of rather big vehicle. And here, for example, if there is something wrong with the tires back here or something. So this is just a little video explaining the concept. What we've been doing here today is that we have mounted this 8-channel microphone array around the pod. We've set up a software plugin to transfer the 8 channels from the pod to the operating station. And then we have a special sound rendering engine set up, which takes these 8 channels and renders 8 virtual sound sources around the listener.
It's completely silent. It will be helpful to hear trucks, cars, vehicles, bicyclists for safety reasons.
Yeah, so that was actually, they're not using sound today, this company. And just the fact that you can hear that the truck is working was a great benefit. You can hear the backup alarm when you were backing, and you can hear the compressors working and all that. So it's not just listening to the surroundings. You can use this microphone setup. It's also for actually hearing the operation of the vehicle, which could be quite helpful. And as I said, also have contact with the persons around you. This is another setup that we used. We tried this microphone rig in a slightly smaller experimental vehicle, which is on the Royal School of Technology in Stockholm, where they also actually have a motion platform mounted to this chair. It's kind of a compact motion platform. And they're also using a loudspeaker array in this case, and not the binaural rendering. But that works pretty well as well. Next we have what I call augmented spatial sound. That's something also we have implemented in this Lava application, where you can if the microphones won't pick up like the faint footsteps of a person, for example, you can augment that sound. Since the vehicle system has an object detection functionality, so you can it can detect what it has around it, and also detect the object type. So if it's a pedestrian, for example, you get the information. There's a pedestrian at this point, and using that information transferred to the remote station, we can add a virtual sound representing this pedestrian then. And then we used basically, we render the type of sound that the source represents. So for example, if we have detected a pedestrian, we play a footstep sound. Like this. So the sound is not the actual sound from the pedestrian, but it's actually my shoes making these sounds, and rendered in 3D or spatially via binaural synthesis. Can also add some augmented tricks to the propulsion sound. We can generate propulsion sound, not use the car's or the truck's own sound, But we create a sound which is sort of realistic to give you the sensation of actually being there. But we can add some features to the sound, like here at 50, 60, 70, and 80 kilometers per hour. So when you hear or you're accelerating the vehicle, you hear some distinct features here, which tells you, okay, now I'm 50, now I'm 60 and 70. So you don't actually need to look at the speedometer to understand how fast you're driving. I don't know. I will play the sound. I'm not sure it comes out properly. It didn't previously, but if you listen, there will be some faint sine tones coming in at different speeds. So this sound represents an accelerating vehicle. The idea is to give you still a realistic sound, but with some added sonic features, which allows you to drive in the proper speed. So we made a simulator experiment to test these things. Yeah, since this was quite difficult to test in real life, we need to use a simulator. And we saw, for example, that you can increase the situational awareness from having these spatial sounds added, helping people to localize pedestrians and cyclists, and increasing their knowledge of what's going to happen in the next few seconds. We also saw that the speed regulation performance is actually better with this speed guiding sound on. So we see that the task was to keep 50 kilometers on certain stretches, and with the red propulsion sound on here, you get the mean is almost exactly 50, while if you don't have the sound, you drive a little bit too fast. And you also vary your speed more if you don't have the sound compared to if you have the sound on. So it seems to have some benefit, this too. But to really pin down a little bit more fluffy aspects of the operator's performance, we're now testing, measuring the brain waves of the operators to measure things such as cognitive load and drowsiness and motion sickness, which also can be a problem when you're driving remotely, and the attention. So that's our current research together with the company InnoBrain in Stockholm, which has this EEG measurement devices and software. Yeah, summing up, I think that auditory displays, it's of course an emerging field of research as the whole remote operations field. But sound seems to be very important, since it can convey aspects that are important for the operator, increasing the sensation of being there, the situational awareness, and the speed keeping performance. And we think that, and also going further, we'll not only investigating remote driving, but also how we can use sound for remote assistance and monitoring these more high-level control use cases. Thank you for your attention. Thank you, my dear colleagues.